This is clip 362, independent events and probability trees. So there's quite a lot of information in these questions. There's two different ways you can do this, either using probability trees, diagrams, or you can use combinations. So I'm going to do an example using both and just see which one you prefer to do. So question 1 says there's a bag filled with 5 blue, 6 red and 2 green marbles. So the first thing to note is how many are there altogether. So 5 and 6 is 11 plus 2 is 13. So there's 13 marbles altogether. Marble is taken at random from the bag. So at random means there's no bias in it. The colour's noted and it's replaced. So that means it's replacement, which means the probability won't change. Later clips, later tasks you're going to do this week, it will be where it's been a non-replaced, so it's left out. So this is replaced, which means that the probabilities won't change. Another is taken. What's the probability of getting 2 blues? So using a probability tree diagram, you can do 3 for the start because there's 3 different colours. So blue, green and red. Then you're doing it a second time, blue, green and red. So as you can see, you'll need a lot of space to do this because it can become quite tightly packed. So what's the probability of getting a blue? Right, there's 5 blue out of 13. Green, there's 2 green out of 13. Red, there's 6 red out of 13. And then because it's replaced, all the probabilities will remain the same. So on here, we'd have 5 over 13, 2 over 13 and 6 over 13. And then the same with these two. I'm not going to fill them in because there's not much space. So what's it asking you? If you take 2, what's the probability of getting 2 blues? So getting a blue is 5 over 13. And then again, if you take it again, because it's put back in, there's still 13 in, and there's still 5 left. So remember in the clip before we said about this and or. So if it's or, you would add the probabilities, and if it's and, which is this is blue and blue. So you're looking for blue and blue, which is and. And means you're going to times them together. So 5 to 25, 13 times 13 is 169. You don't ever have to simplify probabilities. Okay, the second one. So for this one, we're going to use combinations method rather than drawing out a tree diagram. I personally prefer this. There's less writing as long as you understand probabilities and how to write them down. So it says a fair spinner has 12 equal sides sections, 3 red, 4 blue, 5 green. It's spun twice. What's the probability of getting not a green and then a green? So you want not green and green. So remember this notation, probability of not green and then green. So what's the probability of it not being a green the first time? So there's 4, 7 that aren't green. So 7 out of, and there's 12 sections. Then a green, what's the probability of getting it a green? So this time, there's nothing to do with replacement because you're spinning it, so its probability stay the same each time. So a green is 5. 5 green out of 12 altogether. So that's the probability of being not green. That's the probability of being at green. And what do? Well, you want both of them to happen. So it's and, which means you have to times them together. So square number, 12 times 12, 144. And the top will be 7 times 5, which is 35. Again, you don't need to simplify. And notice how much shorter the working out is, because most of what you're doing, the working out you're trying to do in your head by deciding what the probabilities are. So I could have done this first one using the same method. What's the probability of getting a blue? 5 over 13. What's the probability of getting a blue again? 5 over 13. And we know it's and, so you times them together. And I wouldn't need that tree diagram at all. Okay, so you decide now which method you prefer out of those two. That takes a bit more work, but it's laid out for you to be able to clearly follow the route. and this way using combinations. If you understand the probabilities, that's the key part that you're going to use then later on the harder topics.